Yes, sir.
An urn contains 5 red and 5 black balls. So it contains 5 red and 5 black balls. First, we will draw a diagram, tree diagram. Then one ball is drawn. A ball is drawn at random. That means one ball is drawn from the urn. Okay. Its color is noted. Its color is noted. So if one ball is drawn, so its color may be red or it can be black. Okay. Two additional balls of the same color drawn, noted, is returned to the are put in the urn, and then a ball is drawn at random. So two more balls of the same color. If red will come, then two red balls will be added here. Okay. So 2 plus 5. 2 plus 5 red balls and 5 black balls. If you see this part, so here we have to add the 2 black balls, 5 red balls and 2 plus 5, 2 plus 5, that is 7 black balls. Okay, because it is given that two additional balls of the color drawn are put in the urn. If red drawn, then we will put two more red balls. If black is drawn, then two black balls are added in the urn. Okay. So first of all, probability of this E1. E1 is the probability of drawing first red ball. This is E1. So probability of drawing the red ball is equal to first red ball. How many red balls are there? 5. So 5 upon 10. E1 is 5 upon 10. And probability of drawing black ball is also 5 by 10. Now if second ball is, find the probability that the second ball is red. So if you draw the second ball red, the probability of red ball when first ball drawn is also red, already drawn red ball. So that will become 7 by 12. And similarly, probability of drawing the red ball when first ball has been drawn already, that is black. So red ball is here 5 and 12, total is 12. Okay. The question is find the probability that the second ball is red, and it is, what is the probability that the second ball is red? So probability of second ball is red. Probability of that second this ball is red will be equal to sum of these probabilities. Probability of E1 into probability of drawing the red ball when E1 has happened plus probability of E2 into probability of drawing second red ball when E2 has happened already. So this is the law of total probability. So use it. We is 5 by 10 into 7 by 12 plus 5 by 10 into 5 by 12. So 5 2 the 10, 5 2 the 10, 7 upon 24 plus 5 upon 24, so 12 upon 24, 12 to the 24, 1 by 2 is the answer. Bag 1 contains 4 red and 4 black balls. So bag 1 contains 4 red and 4 black balls. Another bag contains, so bag 2 contains 2 red and 6 black balls. Okay. One of the two bags is selected at random. So selecting a bag, E1 is the probability of selecting a bag 1. PE1 is the probability of selecting bag 1, and probability of selecting bag 2 is E2. Okay, got it? So this is the probability of selecting bag 1. That is, it is equally likely events, so 50%, 1 by 2 and 1 by 2. So one of the two bags is selected at random, first part. And a ball is drawn from the bag which is found to be red. A ball is drawn from the bag which is found to be red. The probability of drawing a red ball from bag 1. So how many red balls are there? 4. And total number of balls are 8. 4 by 8. And here the probability of drawing the red ball from bag 2, probability of drawing red ball from bag 2 is how many red balls are there? 2 by 8. Find the probability that the ball is drawn from the first bag. The red ball already drawn, it is from the first bag. The probability of, we have to find the probability of drawn red ball is from bag 1. And as I told you, by this theorem, we can write probability of this should be inverted. Red ball drawn from first bag, probability of selecting the bag, divided by probability of E1 into probability of drawing red ball from E1 plus probability of E2 into probability of drawing red ball from bag 2. Just substitute the values. We get here 4 by 8 into 1 by 2 divided by 1 by 2 into 4 by 8 plus 1 by 2 into 2 by 8. So 4 by 8 to the 16. Here also 4 by 16 plus 2 by 16. So 4 by 6. 2 to the 4, 2, 3 is 6. So 2 by 3 is the correct answer. Yes, question number 2. A bag contains 4 red, 4 black balls. So bag first contains 4 red and 4 black balls. So this bag is containing 4 red and 4 black balls, and the Another bag contains 2 red and 2 black balls. So second bag we have taken, it is containing 2 red and 6 black balls. One of the bag is selected. So our first part is bag is to be selected. So we can select the bag because they are always equally likely events. So 1/2 is the probability of selecting bag A. E1 is the probability of selecting bag A. So 1/2 is the probability of selecting bag A, and 1/2 is the probability of selecting bag 2. After selecting bag A ball is drawn from the bag and is found to be red. So when first bag is selected, now we have to take out the red ball from the bag 1. There are 4 red balls and total number of balls are 8. So 4/8 is the probability of selecting the red ball from bag A. And probability of selecting red ball from bag 2 is 2/8 because there are 2 red balls out of 8. So 2/8. Now we have to find that the ball drawn is from first bag. When we have drawn the ball, that is red, already drawn. So now we have to find that it is from bag 1, E1. So E1 upon R we have to find out. This will be equal to PR upon E1 into PE1 and sum of the all probabilities, substituting the values 4/8, 1/2, 4/16, 4/16 plus 2/16. LCM 16, 16 will cancel. 4/6, 2/3 is the answer. Question number 3. Question number 3. Of the students in a college, it is known that 60% reside in hostel. So reside in hostel 60% means 60% are hostelers. 60% reside in hostel. So even is the event residing in hostel, and 40% day scholars. So 40% are day scholars, that is E2. Overall distribution is this one. Okay. Now previous year's results reports that 30% of all who resides in hostel attends A grade. Okay. Till here, 30% who resides in hostel. So first of all, PE1, what will be PE1? 60%. That means 60/100. So PE1 will be 60 upon 100. And similarly, probability of day scholars will be 40%. That is 40 upon 100. Okay. Now, if this result, previous year's results show that hostelers attend A grade 30%. Okay. So they attend A grade 30%. So 30%, you can write 30% attends A grade. So probability of attaining A grade when they are from hostel E1, A upon E1 is 30%. That means 30 upon 100. Very simple. Similarly here, when they are day scholars, so attends A grade, how much? 20% of the day scholar attends A grade. So 20%, that means 20/100. Okay. Probability that the student is from a hostel, hosteler. He is a hosteler and he attends a grade A. So one of the student is selected and he got grade A. We have to find out that he is from hostel. So probability of, we have to find from hostel. So E1 is hostel. So E1/A. That means the probability, we have to find the probability that the student select the student attend A grade is a hosteler. Correct? One of the student is selected, he is a hosteler. Now you have to find he is from, he attends A grade, we have to find he is from the hostel. So similarly, as you know that P E1 stroke A, so here we will write P A upon E1, A1 stroke E1 into probability of E1 divided by probability of E1 into probability of A stroke E1 plus probability of E2 into probability of A stroke E2. Now substitute the values. So 30 upon 100 into 60 upon 100 divided by 30 upon 100 into 60 upon 100 plus 40 upon 100 into 20 upon 100. Substituting the values, this value, this value, this value, and this value. So 10,000 will be the LCM. So we are not writing 10,000 directly. 6 3 is 1800 will come in the numerator. Denominator again 6 3 is 1800 plus 4 2 is 800. So 1800 plus 800, 1800 divided by 2600. 0 0 will cancel. 18 by 18 by 26. 2 9 is 18, 2 1 is 2, 2 3 is 6. So 9 by 13 is the required answer. (13.3) Question number 4. In answering a question on an MCQ, a student either knows the answer or guesses. Let 3 by 4 be the probability that he knows the answer, and by 4 be the probability that he guesses. And assuming that a student who guesses at the answer will be correct with the probability 1 by 4. So we have to find that he knows the answer. The student knows the answer. So let A be the probability that answer is correct. Answer is correct. He answered correctly. So answer is correct. Okay. That we can write later on. So he knows the answer. There are two possibilities. He knows the answer. So he knows the answer is E1. Suppose this is E1. He knows the answer and guesses the answer is E2, denoted by E2. Let then probability that he knows the answer PE1. He knows the answer is 3 by 4. Okay. And he guesses the answer is E2 1 by 4. Okay. This is 1 by 4. Now, assume that a student who guesses at the answer will be correct with the probability 1 by 4. To correct, if he knows the answer and if he tick the correct answer. Okay. if he ticked the correct answer, that means probability of correct answer. What will be the correct probability of correct answer? If he knows the answer, he will correct the answer. That is 100% 1. So the probability of write the correct answer if he knows the answer A upon E1 will be equal to 1, because he knows the answer. Therefore, 100% chances that he will correct the answer. But if he does not know the answer and he correct the answers, probability of that he correct the answer, it is given that 1 by 4 be the probability that correct with the probability. Who guesses and correct the answer is 1 by 4. So that is given 1 by 4. That means probability of A E2 is equal to 1 by 4. If he knows the answer, he will correct the answer. There are 100% chances. If he guesses the answer and he correct the answer is 1 by 4. What is the probability that the student knows the answer? Knows the answer means this one, and he answered correctly. Okay, so that means A we are using, answer is correct. So we have to find probability from E1 when he knows the answer. Okay, got it? The probability of A by E1 plus probability, sorry, not plus what, into probability of E1 divided by probability of E1 by Bayes theorem into probability of A stroke E1 plus probability of E2 into probability of A stroke E2. So that is equal to 1 into 3 by 4 divided by 1 into 3 by 4 plus 1 by 4 into
Sir,
1 by
sir,
4.
the student is guessing the answer, right? So it should be A by
Yes.
E2, right? A by E2 into P of E2, right?
A by E2 into P of E2, yes.
No,
But
we
the
have to
question
find
is
the probability.
knows the answer. For question is if he knows the answer and he answered it correctly. He answered it correctly and he knows the answer from E1. We have to find A E1. E1 stroke A.
Sir, but
Okay.
before that statement is given, assuming that the student who guesses at the answer will get it correct with probability 1 by 4.
1 by 4. That we have taken. This
Oh,
is
okay,
this
okay,
one.
sir, okay, sir, okay, sir.
If he guesses the answer and he ticked correctly, that is 1 by 4. Okay. But we have to find that he knows the answer and he answered correctly. Okay. He knows the answer given that he answered correctly. Okay. Got it?
Yes, sir.
3 by 4. 3 by 4 plus 1 by 16. So this will be 3 by 4 numerator and denominator LCM will be 16. So 12 plus 1. So 3 by 4 into 16 by 13. So 4 is a 16, 4 3 is a 12, 12 by 13 is the correct answer. 12 by 13. Our laboratory blood test is 99% effective in detecting a certain disease when it is in fact present. When a person is positive, then 99% is the detection. So even A we will write later on because A is the test, given that his test is positive. So A, that is positive. Result is positive. Finally, we have to find the result is positive. So first, okay, start from here. 99% actually has disease. Okay, 99% even is actually has disease, actually does not have disease. So okay, even is actually has disease. Now see, test yields a false positive result for 0.5 healthy persons tested, and 0.1% of the population has disease. This is 0.1% has disease. This is the overall population which has disease. So this will be even will be 0.1%. That means 0.1% of the total population has disease, and rest of the population actually does not have a disease. Okay. So how much? How much? 1 minus 0.1. So actually 1 minus 0.1, we are doing it in terms of probability. So here you can write 0.9% when we are going to do the probability. Otherwise, the result will be slightly different. I am telling that probability E1. First, you find the probability of E1. Okay. Probability of E1 is what? 0.1 by 100. And then you will remove the decimal 1 by 1000. So probability of the actual having the disease is 1 by 1000. Huh? And probability of that they don't have the disease, so that is equal to, do not use this one and then write the percentage, otherwise 999 will not come. So here you will write 1 minus in decimal 0.001. Probability of this what? 0.001 in decimal part. Write in decimal part. Everything you should write in decimal part. So then it will become 0.999. So more accurate probability will come. Understood? So convert into decimal, then you will get more accurate results. Okay. So actually has disease. Test yields a false positive result, 0.5% of the healthy person tested. Healthy person means which have disease, yani actually having the disease, and false positive result. Okay, so positive result but false 0 point, but 99% is detecting a certain disease when it is in fact, first part, this one, 99% in detecting a certain disease when it is in fact present. So in fact present, then 99% are giving positive results. Okay, so positive results are here 99%. Okay, because here it is given. So probability of they have disease and their test detected positive is 99%. That is 0.99. Got it? Okay. And test yields a positive, false positive result for 0.5% of the healthy person. If a healthy person is tested, then the probability the test will imply he has disease. So 0.005% is positive result. If they don't have disease, means they are healthy person. Healthy person means does not have disease. Healthy person means actually they does not have the disease. They are healthy. Okay. And their positive result is 0.5%. So that is probability. That means positive result is how much? 0.5% as per the given data. So probability of healthy persons having positive results is 0.005. Okay, so convert in decimal, then you will get the answer as per your textbook. Otherwise there is a slight difference in the answer, no problem. So probability of that, the given that his result is positive and he has it, he has actually disease, that means E1. So E1 by E1 stroke E we have to find out. Got it? Till here, any doubt? The probability of A by A stroke E1, probability of E1 divided by probability of E1 into probability of A stroke E1 by Bayes theorem. In every question you can write here by Bayes theorem. Okay. So plus probability of E2 into probability of A stroke E2. Okay. Now substitute the value 0.99 into 0.001 divided by 0.001 into 0.99 plus 0.999 into 0.005. So you will get here 9.9 into 10 raised to power minus 4. Here you will get 9.9 into 10 raised to power minus 4 plus 4.995 into 10 raised to power minus 3. You have to make it minus 4 power. So divide by 10 and multiply by 10. So one decimal place will be shifted. So you will get 9.9 and powers will cancel. Here 9.9, here also 9.9. Here it will become 49.95. So the result will be equal to 99 upon 598 and 0.1654. Final result. Okay, 1654. So E1, E2, E3 is the selection of that coins. Up now, second is probability of head coming head in the two-headed coins. The two-headed coins, 2 out of 2, that is equal to 1. Okay, then probability of getting head in biased coin. So biased coin is already given 75%. So 75 upon 100, that is 3 by 4. Huh? And probability of getting head in unbiased is 50%. So half 1 by 2. So we have to find the probability of E1 stroke H getting head on the coin head getting, and it is already given that from E1 means two-headed coins. So this probability is the coin is two-headed. Given that it shows head. This you should write. Probability, you should explain everything in examination. Probability that the coin is two-headed. And given that it shows head. So probability of H stroke E1 into probability of E1 divided by probability of E1 into probability of H stroke E1 plus probability of E2 second event, probability of getting head when E2 has already happened. So this will be equal to, just substitute the values. 1 by 3.
Sir, there are three events,
divided,
right?
yes, one more is left. Probability of E3 into probability of H stroke E3, 1 into 1 by 3 plus 1 by 3 into 3 by 4 plus 1 by 3 into 1 by 2. Solve it, you will get 4 by 9, correct? Is that it?
Yeah, sorry, sir. 4 by 9.
An insurance company insured 2,000 scooter drivers, 4,000 car drivers, 6,000 truck drivers. So there are three events. How many events are there? 2,000, 2,000 scooter, drivers, and this is event number 1. Event number 2, 4,000 car drivers. And event number 3, 6,000 truck drivers. 6,000 truck drivers. Okay. So what is the probability of getting the scooter drivers? The total is 12,000. The probability of scooter drivers is 4,000 upon 12,000. Correct? That is equal to 1 by 6. The probability of getting car drivers is 4,000 upon 12,000. That is equal to 4 3 is a 12. 1 by 3. And the probability of truck drivers is equal to 6,000 divided by 12,000. 6 to the 12, 1 by 2. Okay. The probability of accident 0.01 by scooter driver. Probability of accident by scooter driver. Probability of accident A from scooter driver. Probability, it is probability 0.01. Okay. The probability of accident by car driver is 0.03. Probability of accident by truck driver is 0.15. If accident happened, Lot of insurance person needs an accident. What is the probability that is from a scooter driver means E1. So we have to find E1, probability of E1 when accident is already happened. The probability of A by E1 into probability of E1 divided by probability of E1 into probability of A stroke E1. There are 3 events here. So we have to add all the 3 events. Probability of A stroke E2 plus probability of E3, probability of A stroke E3. Substituting the values. 0.01 into 1 by 6. Divided by 0.01 into 1 by 6 plus 0.03 into 1 by 3 plus 0.15 into 1 by 2. So removing decimal, I'll write here next step. 1 by 600 divided by 1 by 600 plus 3 by 300, that is 1 by 100 and 15 by 200. Again, we are saying 600, so 1 by 600, and here LCM will be again 600. So here 1 plus 6, because 3 will cancel, plus 45. We get 1 upon 52 is the required probability.
Question number 8. Okay, this type of question we have done before also. Factory has 2 machines, A and B. The machine A and machine B. Machine A produce 60% of the output. So machine A is having 60% output. Therefore, probability of machine A production of machine A is 60%, that is 60 upon 100, that is equal to 3 by 5. Okay. Then machine B produce 40% of the items. Machine B produce 40% output. Is 40% output. So this is our event 1. Event 2. The probability of E2 is 40%, that is 40 upon 100 or 2 by 5. Okay. Now 2% produced by A machine are defective. 2% produced by machine A are defective. The probability of defective items produced by machine A, defective items. Okay, so we can say A as the produced defective item. The event showing produced defective item. So Probability of machine A producing defective item is given 2%. Yes, so 2 upon 100. Similarly, probability of producing defective item by machine 2 is 1%. That means 1 upon 100. So an item is found defective. We have to prove that it is from machine B. Probability that it was produced by machine B. Chosen defective item is probability of chosen defective item is produced by machine B. We have to find out probability of E2. Okay, that means probability of chosen defective item is from machine B. So that will be equal to probability of A stroke E2 into probability of E2 divided by probability of E1 into probability of A stroke E1 plus probability of E2 into probability of A stroke E2. That will be 1 by 100 into 2 by 5 divided by 1 by 100 into 2 by 5 plus 2 by 100 into 3 by 5. 500, 500, 500. So we will write on the numerator 2, 2 plus 3 to the 6. So 2 by 8, so 1 by 4 is the required probability. So group 1 wins and group 2 wins probability are given. So there are two groups. Group 1, let's say group 1 and group 2. Okay. So group 1 will win a 0.6. So group 1 probability of group 1 wins is 0.6 and probability of group 2 wins is 0.4. If the first group wins, the probability of introducing a new product is 0. If they wins, both are the winning probability. So then they will have to introduce a new product. So probability of introducing new product by group 1 is equal to 0.7. Correct? That means this is the probability of introducing a new product from group 1, that is 0.7. Similarly here, producing a new product by group 2 is also given as 0.3. So A by E2 is also 0.3. So everything is given. Find the probability that the new product introduced was by the second group. So E2, second group is E2, and A is the probability of new product. So this is the probability that new product introduced was by second group. So similarly, you have to write probability of A stroke E2 into probability of E2 divided by probability of E1 into probability of A stroke E1 plus probability of E2 into probability of A stroke E2. Substitute the value 0.3 into 0.4 divided by 0.4. This is 4. 0.6 into 0.7 plus 0.3 into 0.4. So 0.12 divided by 0.42 plus 0.43 is 12. So 0.12 upon 0.54. So that is equal to 12 by 54 and 6 to the 6. So 2 by 9 is the required probability.